Let's talk about the meaning of the special permission bits for files. Those bytes applies when we try to execute the file. If not, they doesn't have any meaning for files. And for the 3 bytes, remember that we have the setuid, setgroup and the sticky bit. The sticky bit is not used anymore for files. It was used for keeping some programs in memory and to reuse, to avoid loading them more than one time. But it's obsolete and it's not used anymore. So we only have the setuid and the setgroup bits for files. They work in a similar way and allows a user, when a user runs that file, a file with the set UID or set group ID bits set, then the process created will will behave as if it had the same permissions as the owner of the file. So for example, here I have this program, my top, so I will switch to another user. Okay, okay, and I will run the my top command. This command only shows a list of the processes running in our machine. And if I query all the processes running in the machine, here I have my top, and the user of my top, Elmo, is the one who is running my top. Okay, because Elmo launch the process, and remember we have a file, a user create a process, and the permissions are checked through the users the user who launched that process. And but here, if I set the set UID bit on that file, okay, I will finish the process, set the set UID file on my top. Okay, we can see here that we have the executable bit and the setuid bit. And now if Elmo runs my top, then see the difference. Here we have my top, but the user running my top is the owner of the file. It's not Elmo anymore. So Elmo, each permission checked by that command will be it will be like if that command will have been launched by user, not by Elmo. Okay, so it's like user had launched my top instead of Elmo. Okay, and this is something very dangerous because, for example, my top only shows a list of processes, doesn't do anything else. But, for example, my cat is a copy of the cat command, and if Elmo, for example, tries to use the private txt file, for example, it won't be able to do that. Okay, permission denied because only user can see the contents of the file. But if I set the set UID to my cat, the set UID bit to my cat, then anyone who runs the mycat command will be able to do the same as user. So if user has access to this file, to private, then using mycat, you will be able to access that file. So for example, okay, if I use mycat private, okay, I can see the private contents, okay? I shouldn't be able to see the contents because I'm Elmo, and only user can see the contents of my file, but because my cat has the set UID permissions, I can run my cat as the user, the owner as user, and I can see the contents of the file. The same happens for the group. You see, if I set the set group ID instead of the set UID group, then the process I create will be working with the group who owns the file. So for example, if I set here the set group ID, cat, and sorry, I mean, okay, and I remove the, the, the set UID, okay, now I have, sorry, I will remove this and add the group, okay, now I have the right permissions, okay, it's failing because Muppets user doesn't belong to the group Muppets, so I need to use a sudo. Okay, so if I have this, if I have the set group ID, if I run the command mycat, then it will be running as the group Muppets. So for example, if I change private Muppets, I will need to use sudo. Sorry. And I give read permissions to the group. Okay. No Elmo doesn't belong to Muppets, but I can see the contents because when I run my cat, I will be running this as the user Muppets. So to get it more clear, I will remove the permissions for the user. Okay, only the group can read the contents of the file, and I can do this because my cat will be running as the group Muppets. So set UID and set group ID allows to run commands in behalf of another user or another group. And this will work only for commands, not for scripts, because for scripts it will produce a security problem, and it will work only for executable files, not for scripts.